everyone. In this demo, I will be presenting a FactoryPulse project, which is an intelligence manufacturing analytical platform built using Azure, Microsoft Azure and Databricks, and also Azure Data Lake Gen 2 with Azure Event Hub, Delta Lake, Unity Catalog, and MLflow and Databricks AI and BI dashboards. So the goal of this project is to simulate how a modern data engineering platform can help manufacturing teams monitor machines, detect anomalies, analyze operational KPIs, and predict potential failures. All the data I used within this project is a synthetic because real manufacturing data is confidential. So yeah, first of all, let's get into the architecture overview. So as you see here, the platform starts with a local Python file that generates data like manufacturing like data sets such as the machine telemetry, production, runs supplier, delivers, maintenance logs, and quality inspections. The batch data is uploaded into Azure Data Lake Gen 2 using the API CLI Azure API. The data is organized within Azure Data Lake Gen 2. The storage using a medallion architecture, bronze, silver, and gold. For the real-time data, we built a Python IoT simulator that sends machine telemetry events into Azure Event Hub, and then Azure Databricks consumes both the batch and streaming data using PySpark and structured streaming for the real-time data. So the data is processed into delta tables and governance is assured by the Unity catalog. Finally, the analytics outputs are exposed through the Databricks SQL views and visualized using the Databricks AI BI dashboards within Databricks. And also the batch pipeline is the first part of the projects. So here, in order to get the project overview and solution design well, so in the bronze layer, I store raw data as it arrives from the source. Then in the silver layer, I clean and enrich the data. For example, I remove invalid records, I handle duplicates, I create alert flags for abnormal temperature, vibration, and pressure, and calculate a machine health score. Then after that, in the gold layer, I create a business ready KPIs tables such as like machine health KPIs, daily operational summaries, and failure risk indicators. This design follows the medallion architecture, so used in a modern lakehouse platform, which is Databricks. And for the streaming pipeline, the second part is the real-time streaming pipeline. So I create a local Python producer that simulates IoT data and writes them into Unity catalog delta tables. So it sends the events into the Azure Event Hub, which is like a Kafka in this case. So it's built in on Kafka apparently. So the streaming data is enriched with real-time alert logic, so including temperature alerts, vibration alerts, pressure alerts, health score, and machine status. This allows the platform to monitor live machines behavior and detect critical machines in a near real-time streaming. Then we have the dashboard explanation. So the dashboard is designed as an executive and operational monitoring cockpit. So in the first section, we have the executive overview showing global KPIs such as the average. So I'm gonna jump into it like this is the results of the project. So here we have the executive overview. It shows the global KPIs such as the average machine, health scores, active machines, total alerts, and failure risks, etc. We can filter using days, and also like choosing specific machines and stuff. And there is the predictive maintenance part. So in here we can identify machines with high failure probability and analyze their temperature, vibration, and pressure patterns. So there is the average failure probability, how machines above like 17% of risk, and all the details about the predictions. And also there is the MLOps model monitoring, so the average failure probability and stuff. And this is like near real time. As long as the notebooks are running, we're gonna go through every part of the architecture we just have seen before. Then we have the operational monitoring page. So here this section shows machine status trends, average temperature, vibration, and alert evolution over time. And also we have the risk and alerts. So this section uses streaming data to show the latest machine events and highlights machine currently in warning or critical status. You have this pagination for high risk machines. So the idea is not just to display data, but to create a real operational intelligence layer for decision making. Then for the machine learning layer, for the ML, so I trained a failure prediction model using machine telemetry features such as temperature, vibration, pressure, and RPM, power consumption, and health score. The model is trained using scikit-learn and tracked with MLflow. The model predicts whether a machine is likely to fail and also generates a failure probability. The prediction results are stored back into Delta table and visualized in the dashboard. So this creates a full loop from the data ingestion to machine learning predictions to business visualizations. So for the governance and production thinking, so we have the catalog, so Unity catalog. It's used to manage schemas, tables, views, and volumes. For streaming checkpoints, I used Unity catalog volumes instead of public DBFS because the workspace is configured with stricter governance settings. So it involves many problems that solves with using volumes. And that's the full picture of the project. So now let's get into the platform. So first of all, we have the Microsoft Azure platform. So here we created our resource groups. For this case, we have created the RG FactoryPulse dev resource groups. It's here where it contains all my services. So we created the storage blob storage with the containers. We have like the bronze, gold, raw, and silver. So first of all, we have the raw container that contains our data. In this case, I didn't use it in here because the idea was, let me show you in here. So first of all, I have my data in raw within my local machine. So I have the delivery packet, IoT telemetry. All of this was generated using the this file. You will find it within the GitHub that I will put in the description. So after running this code, this data will be generated, and then in order to like have this data uploaded into our container. So first of all, we have the okay, so okay, let's go to the containers we're talking about. So first of all, we have the bronze. Okay, so in order to have this data in here, we have to install the CLI of Azure. So if we went in here, so you have to install the CLI, then you're gonna find the installation in the Microsoft platform. Then after that, I run this command, which is source blob upload batch. Then I put here my account key that you're gonna find within the platform in the access settings, and then all the files that are within my file in here are gonna be uploaded into the container, which is what happened in this case. And after that, within the notebooks will be using this data within the bronze, and then we're gonna upload the processed data within silver and gold layer. So this is for the storage service. Then we created a Databricks instance in this case, and you're gonna launch the workspace. So in here the interface will be like this, going to the home like this. Then you're gonna create a workspace, and within the workspace I created this folder that contains all my notebooks and my dashboard and my queries, and also my job pipeline that we'll be talking about later. And then we created also Microsoft's Azure Data Factory Studio, and like by launching, click Launch Studio in order to create this pipeline. So this pipeline comes after we create the 3 notebooks, and then we try to trigger this execution of the 3 notebooks using a pipeline created within the data factory. So first let's take a look at the 3 notebooks we just created. So here I have the bronze ingestion notebook. So here we first of all we set the storage account name, storage account key, and we start by configuring the Spark configuration for the Azure key to access the files, the package files stored within the bronze container. And after that we read the data, we display it, and we test the connection. Is it it's done? Then we write into the Databricks Unity catalog. And then for the silver transformations as specified, this notebook contains the transformation we made. Then we store into the silver schema. And then for the gold notebook, it has the aggregations and stuff that we used for the dashboard. So this is the code we have. And then we trigger the execution of these 3 notebooks using this pipeline. So that's the idea, and we gonna publish the pipeline. So that's the first part of our code, of our project. And we use this access connector for Azure Databricks just to make the connection work between the execution of the pipeline and the notebooks. So that's the parts in here. What else do we have? We have also this Stream and Event Hub notebook. So here, first of all, we have this file, Python file. So generate factory data. So within here, the script runs like sends 10 telemetry events every while of the time, and then so it actually sends the data into the Event Hub. So what is the Event Hub? It's created also within our within our Azure portal. So we created this Azure Hub events that takes the data like from the Python file, and then streams the data into our notebook in order to create a streaming streaming pipeline. So this is what actually it does, and yeah, so this is the script. So we create the schema bronze and silver, and we try to create a stream like Spark streaming workflow where we read real time data. So the events here are stored in this table, and then we try to like parse and have a schema for our stream, and then we store the results for the bronze and the silver in order to work for them later with them. Then for this notebook, it contains the ML model created, the machine learning model we created, and then actually we have this notebook for the feature engineering part, and then finally we have this batch inference notebook. And for this MLOps like CI/CD pipeline, we created a job for that, which is this job. So the job is in here. We have this feature engineering notebook. After it runs, it will run the training notebook, then the batch inference every time. And here for let me see, I have also those like views. So this just SQL queries where I make like I validate is the data ingested successfully after running the notebooks and the pipelines and stuff. And yeah, so and also for creating the views used within the dashboard here, because the dashboard actually reads the data from the views we created. And that's the idea. So for example, for here I'm checking if the data of machine failure features is actually ingested, and that's what's happening actually. So that's in a nutshell the projects we built using like Databricks and Microsoft Azure. This project demonstrates several real-world data engineering skills. So we used Azure Data Lake Gen 2 storage architecture, Databricks Lakehouse design, Delta Lake medallion architecture, PySpark batch processing and structured streaming, Azure Event Hub integration, and we Unity catalog governance. We used SQL views for the analytics, and also we used AI, BI like dashboarding, MLflow experiment tracking, machine learning batch inference, and MLOps style workflow organization. So in a nutshell, to conclude, FactoryPulse is a complete manufacturing analytics platform that combines batch processing, real-time streaming, dashboarding, governance, and machine learning. So the project is built with synthetic data, but the architecture reflects a realistic enterprise use case that can be adapted to manufacturing, supply chain, predictive maintenance, and operational monitoring scenarios. So thank you for watching.